Hey, good afternoon. Just setting up a spot here for my, whoops, that's not gonna work that way. Let's put it this way. Okay, let's get that straight there. Okay, so hey guys, so today I'm just going to be doing a video here today on, we're starting electrostatics. So we're going to look at an electroscope that we're going to use, and I'm going to show you a couple things about charge, static charge, and so forth. And so we're going to just split today into two little videos. This one here with the camera. It's not the best camera in the world, as we probably know already. Get this straight a little bit. But we're going to use this camera to show a little bit about the electroscope. So let me go grab an electroscope here. Okay, and I'll adjust the camera here so that you can see the electroscope, hopefully. Get this lined up. Okay, so let's adjust the camera here. Okay, so in here we see the electroscope. Let's get this set up better. Okay, there's the top of it right there. So here we have, this is a conductor here. So a conductor is a material that lets electrons flow through them easily. Then here we have a metal bar in here. There's an insulator, this plastic piece here. And underneath we have these two leaves here. And what these two leaves are doing are they're going to detect charge. Okay, so that's what we're going to be watching here. I'm going to maybe zoom this out a little bit. Oops, wrong way. So that we can see the whole piece there. Okay, so here's our electroscope. And in here, okay, good. So these leaves here are metal leaves, okay, and they are attached to the conducting rod here. So what we're going to do is if we charge objects through here, these leaves will spread apart if there is a charge on this object. So what we've got here is we've got a couple of electrostatic things that we can charge with. Okay, just going to get some flannel here. Okay, so if I've got some ebonite rods here with points on them, okay? And if we charge these up by friction, so friction, how friction works in terms of charging something is that the friction, basically the motion of the friction takes any loose electrons and transfers them from one object to the other. So both objects have to have opposite attractions towards the electrons. One will have to have a strong attraction, one will have to have a weak attraction. So therefore the electrons will move to the object that has a strong attraction. Okay, so if I charge this up, most of the charge should be focused at that point. And if I bring it close, you can kind of see it moves those leaves just slightly with electrostatic charge. Okay, not a great big charge, but if I bring it in there close, you can see that it causes the leaves to move. So that's an electromotive force. So if I touch it, they should stay apart. Well, it's probably not the best insulated one I've got here. So let's see if we can get a larger charge with some different materials. Let's try the brass rod here. Try some of this fake fur here. Might work better. Okay. So I'm just using a plastic ebonite or a plastic lucite rod that's plastic. Oh, this one I can hear. And this fake yellow fur, what they used to wear in the 70s. So this should be a stronger charge. You can hear the crackling there. Okay, let's see what happens. So there we can see it's, and I'm not touching yet, but if I touch it, the charge transfers to that object and they stay spread apart. Okay, if I move it away, they should stay spread apart a little bit. Now, if I touch it and ground it with myself, because I'm touching the ground, they should go back. Okay, not a lot of movement there, but a little bit. Okay, just going to pause for a second here. If I can find my pause button. There it is. And I'll be right back with you. Okay, so I'm just back again. So I'm going to try this glass rod here. See if we can. So that grounds it when I touch it like that, because all the electrons flow into me. See if a glass rod, a hollow glass rod, works a little better. That's pretty strong. So when you bring a rod that is charged, so what's happening is electrons are either transferring to the rag or to the rod. And then if you bring it close to your electroscope, the electrons spread out along the conductor. And because the electrons are down there, or the positives are down there, they spread apart because they repel each other. Okay, so let's get it grounded here. Let's see if I can get a good charge on it. Okay, that one worked pretty good. Look at how much I could spread those apart by touching it. So if I let this go, they should stay spread apart. Okay, so this is charged now. So the glass rod worked way better than the ebonite rod with the fur. So now this thing has been charged by contact. So I've charged up a rod, brought it close, touched it. Either the electrons flowed onto it or flowed off of it, and now there is a charge in that electroscope there. Now if I touch this, I'll discharge it or ground it. All the extra electrons will flow onto me into the earth, and they should fall down. Okay, so that charging by contact is by touching it. So I'm going to show you that one and explain that in our notes later today. The other one that can happen is charging by induction. So you can also charge something like this. Let's get some more charge on this glass rod. It's nice and hollow so that there's more charge on the edge. Okay, so charging by contact is by touching something. Charging by induction is if you bring it close like this. Let me get some more charge on it so we can. Okay, so you bring it close so that at least, notice I'm not touching. Then I touch this so that and then I remove this and remove this. That didn't work too well there. That's called charging by induction, but it didn't work so good. Let's try it with the ebonite. Maybe I can get a little bit more with the ebonite for induction. Okay, so bring this close without touching it. Touch it with your finger. Should move this. Move this. They should spread apart. Let's see. Nah, it's not working. I don't get enough charge. Maybe if I charge with the raw. See if the rag is charged. No. Let's try a balloon maybe. A balloon might work. Just going to pause and go find a balloon. Okay, so I went and dug up some balloons here. So these should be able to give us a little more charge than what we had with the other ones there. Those ones are pretty small. That's going to cause me to blow up my blood vessels in my forehead. Let's try a little. Oh, that's squeezy one there. Here's a nice big one. Let's use this one. Okay, so what we'll do is we'll see if we can get more charge with this balloon because it's a nice thin layer of rubber or plastic or whatever it is. Okay, I don't have very much hair, even though, so we'll use this fake fur here. And we'll see if we can get a huge amount of charge on this balloon here. Okay, notice it does have an attractive force. So one of the, even though these are opposite charges and you're like, hey, don't, well, they attract each other, right? So what we're going to do is we're going to get this balloon charged up nice here. Okay. Not enough yet. We'll see if I can get more on here. Okay, you're like, aren't you grounding it over here? Yes, but with an insulator like rubber, the charge stays in the area that you charge. It doesn't spread evenly like it does on a conductor. And then we'll do all that in notes here later. Today or maybe tomorrow, depending on how long I sit here playing with the electroscope. It's kind of fun. Okay, so I've got this fairly well charged. There's a fairly good attraction for that. As you can see, like it really wants to stick to the fake fur there. So if we bring this, oh, look at that. Okay, if I bring this close, okay, I gotta discharge myself here. If I bring this close, it's spreading that pretty good, right? So charging by induction, I hold the balloon close without touching it. I take my finger. Okay, I'm losing some charge. I want to charge it up a little more. Get it on the bottom here. And I'll explain how this works in diagrams here later today. Okay, charging by induction, I bring it close like this. Okay, touch it with my finger. Take it away, take my finger away. It's not working great. There, I have to keep the balloon close. I forgot that step. Okay, so let's do that again so we know what we're supposed to do. So charging by induction. Okay, we charge the object up, whatever we're charging with, this balloon in our case. Okay, we get that, we bring it close to the electroscope. We touch the electroscope with our finger so that it's discharged. We remove our finger, take the balloon away, and there it becomes charged. And that gives the opposite charge of whatever this balloon is. So if I want to take that and ground it, there it's grounded. Okay. Hopefully everybody can see those. So again, charging by contact, touching it with the balloon, taking it away. Okay, it's slightly charged there. Grounding it. Charging it by induction is bringing it close. Right, bringing it close, touching it with your finger, leaving the balloon there, removing your finger, removing the balloon, and it's charged the opposite way as these two are spread apart. Okay, grounding. Okay, this is an electroscope. This tells us if this object is charged or not. Okay, so that's the little demonstration with the electroscope. If you have one in your school or two in your school and some balloons and stuff, give it a try. Why not? Now, if you do have some of the electroscope stuff and some rods and things like that, dig those out. I'll be using those later on in physics during this unit as well. Okay, so I'm going to stop the camera here. That'll be the first part of our video. And then the next part of our video will be me explaining what charging by contact is and what charging by induction is.